You ever think about what really keeps our cities from, well, falling apart? The answer isn't always in the big, shiny skyscrapers we see. A lot of the time it's hidden in the world right beneath our feet. So today, we're going to go underground and take a look at the incredible science that literally keeps our world from grinding to a halt.
So let's start with a puzzle. How do you fix a critical pipe that's cracked right under a super busy street? The old way, well, that was a nightmare. We're talking a total mess that stopped traffic and cost a fortune. But now, engineers have a much smarter way of doing things.
All right, let's dive in. And to really appreciate just how genius the new solution is, you first have to understand just how much of a headache the old way was.
We have all seen this, right? You're stuck in traffic, and there it is, a massive, muddy trench snaking down the road with huge excavators everywhere. This wasn't just annoying, it meant closing roads, disrupting everything for days, sometimes weeks, and it cost an absolute ton of time and money. You just have to look at that scene and think, come on, there has to be a better way. And you know what? Thankfully, there is. So what's the big idea? Well, instead of digging everything up, engineers can now repair pipes from the inside out. It's this brilliant technique known as the short liner method, and it's a total game changer. Okay, so here's how this magic trick actually works. Step 1, they take a flexible liner. Think of it kind of like a giant sock, and they completely soak it in a special resin. Then they slide that right into the broken pipe. Step 2, they inflate a bladder inside it which presses that resin-soaked liner tight against the walls of the old pipe. For step 3, they cure it. They basically use light or heat to make that resin rock solid, and what you get in step 4 is a brand new, incredibly strong pipe inside the old one. Zero digging, zero chaos. So what's the secret sauce here? What are these liners actually made of? Well, it's not magic, it's just some seriously clever material science, and it's basically a two-part system. First up, you've got the carrier. This is the CRF Plus fiberglass mat. The easiest way to think of this is as the skeleton of the operation. It's the flexible sleeve that gives the whole thing its shape and allows it to be maneuvered into place perfectly. Now, if the mat is the skeleton, then this, the silicate resin, is definitely the muscle. This is the stuff that does all the heavy lifting. It starts out as a liquid that soaks into the mat, but then a chemical reaction turns it into an amazingly strong and durable solid. This is where the real power of the repair comes from. See, it's a perfect partnership. The mat is the delivery vehicle, giving it form. The resin is the powerful stuff that actually becomes the new pipe. You absolutely need both for the system to work, and together, they create a permanent solution that's built to last. Okay, so this all sounds great, but the big question is it actually strong enough? Because when it comes to engineering, you can't just cross your fingers and hope. You need proof. You need cold, hard data. And that proof comes down to a key measure called tensile strength. The concept is actually really simple. Just imagine you're pulling on a rope from both ends as hard as you can. The amount of force that rope can take right before it snaps, that's its tensile strength. And for a pipe that's buried underground with all that pressure from soil and traffic, well, that's a pretty important number to know. That's the bottom line, isn't it? When you're talking about the fundamental infrastructure that our society depends on, you can't guess. You have to test everything, measure it, and prove it can handle the absolute worst conditions. So let's get to the good stuff. Let's actually look at the data. This is where we see the real-world proof of just how durable these things are. Okay, check out this table. This shows the minimum tensile strength that's required for a few different types of these silicate resins, all based on a specific international standard. You see the names: Type A, W, S, and a 50-50 mix. And those numbers next to them? They represent an incredible amount of force they have to be able to withstand. It really shows you how rigorous the standards are here. And this bar chart makes it even clearer. Look how consistent they are. Type W and S are right at 15.0, and Type A is just a fraction behind at 14.9. The point isn't about which one is a tiny bit better. The point is that they are all engineered to meet an incredibly high, non-negotiable standard. They are all exceptionally strong. So, what do these numbers actually mean for you and me? They're a guarantee. They're the scientific promise that this pipe within a pipe isn't just some temporary patch. No, this is a long-term structural fix that's going to serve our cities for decades to come. And this is just one tiny example of the amazing and often completely invisible science that keeps our modern world running. Over 99% of our infrastructure works perfectly every single day because of materials just like this. It's the kind of thing we all take for granted, but it's absolutely crucial. So I'll leave you with this thought. If this much incredible science goes into fixing just one little section of pipe that we'll never even see, what other invisible engineering marvels are out there silently keeping our world running smoothly? Makes you think, doesn't it?